Okay, so here's what I'm going to do. This talk has two parts. One part, I'm going to jabber at you for a bit, and then we're going to have a bunch of example stuff. Okay? And I am going to give the first part without my slides while my wife brings them from home. So we're not out of the woods yet, but fortunately, it broke down that way. So, and then the URL, there's a repo with the example code, which you'll have as soon as that comes. So, here's the origin of this talk. So the title is C++ Things You Were Taught Wrong. If you're a C++ expert, I'm looking at you, Chris, then I'm not going to say anything you don't know. However, I run into a lot of really, really bad C++ that's written by people who are fine programmers in something else, and the company needs one thing written in C++, and they took a class 20 years ago, so they get the job. And this leads to me wishing I was dead so I didn't have to look at their code, and other unfortunate outcomes. So that's the motivation. I have two audiences in mind. The main one is if you're in that situation. And the other one is if you're not in that situation, but you're going to leave code for a company so that the poor maintainer is going to be in that situation, in which case you might not remember which things you don't know. So first thing is, so what are the goals? The goals is you survive your first industrial C++ project that you weren't prepared for, you weren't hired for, and you never wanted to do, maybe. And the second one is either you don't write a ball of mud so nobody ever calls me, or if they do, I'm not under my desk crying because of what you did, because that's how it happens in C++ if you don't know. Okay, that's the talk. So the first thing is mindset. Not going to spend much time on that unless she can finish with this part before she gets it. And the mindset is that you're not prepared for the level of paranoia that you should have. It's always nice to be a paranoid programmer. However, the level of paranoia for working in an unsafe, low-level language is kind of off the charts. So what I want you to do, when you go to bed at night, brush your teeth, get up in the morning, say, Bjarni Stroustrup hates me and wants me dead. Now, it's not actually true. The truth is he sold his soul to the devil for easy incremental upgradability from C to C++, but it has much the same effect. So if you assume he wants to kill you, you will just very quickly, you'll know a few things like the defaults in C++ are probably terrible for you because they're there for somebody that has 50,000 lines of C and not new code. And that just in general, the language has many rough edges. And that you should protect your boundaries. You'll see that. I hope you'll see it. Obsessively. When you have rules for what happens inside your code base and you call something else that doesn't have your standards, then you impose them at the boundaries once and for all. And you'll kind of see me doing that just when I'm trying to illustrate other things. All right. First thing, if you were programming in Python, you would expect to have tooling, okay? You might use, black for formatting if you like. You would have test facilities, you would have virtual environments, and then people come, and since their only experience in C++ is doing homework or exercises off the internet, they go naked and don't use tooling. So the first thing is, tooling, we actually have it, believe it or not. It's just not in one central place because it's a decentralized language. And my slides tell you what I want you to use. The first one is, if you get to choose your build system, and God help you if somebody picks it for political purposes, like, well, the rest of the company is using this. And the answer is, yeah, they're not doing C++. This community has kind of settled on CMake. That's my opinion. So at this point, we should embrace our new CMake overlords, and because it's very nice. And so probably, if you get a choice, that's almost certainly the right thing, unless you need to do something really, really specific. And if you know enough to know that, and know what you need, then this talk isn't for you, unless you're trying to make something simple for someone else. Okay, so CMake. Try to grab, and the other thing is, of course, like any build system, it's a pain to configure, not as bad as, say, Bezel, but so what you do is you grab a reasonable example, and then you hack it. Okay, I have a reasonable example for you, and I hope I'll get you the URL in a bit. But what you want is that the structure is reasonable and that it's modern-looking CMake. So the title of the talk is Stuff You Learned Wrong. If you learned CMake, there's a pretty good chance you did exactly what I did, and you learned it wrong. And the reason you learned it wrong wasn't your fault. It's because there are about 1 million web pages on the internet telling you how to use CMake, and about 9,999 of them are very out of date. So what I wrote for you has the virtue that it does things like it tells you how to build a target in terms of setting properties on objects rather than everything global, with the exception of the build types, which I haven't wedded myself away from yet. So that's really all I want to say about CMake. Oh, the other thing is, if you're used to, say, Python, and you think, where's the package manager? And the answer is, okay. So first of all, let's be honest, we don't have one. We were decentralized before somebody ever thought of a language-specific package. Before CPAN, we were around the world, we're never coming back together, but CMake will do about half of it, because you can tell it to just download and build stuff and make them available automatically, and it's really good at it. So if you want to vendorize things, have CMake vendorize it. Whatever you want to do, if you want to download it, just have CMake do it. It'll do it right, or it'll go find what you have installed in the system. So that's all I want to say, except unless you're having something imposed on you, just use CMake. Second thing. You also are used to having test facilities. You'd like to have a test framework. So any sensible person in the 2000s would go and look at the standard library. There's nothing in the standard library for testing. Well, there's a cert. Okay, so the point is we're decentralized, but there are good ones. My recommendation for you, my new favorite is called DocTest. It's either the worst or the best name ever. It's the worst because if you Google DocTest, it's all about Python, unless you put C++ in the search line. But it's also the best because that means that when your manager hears you want to use DocTest, you go, oh yeah, the Python guys are using that. That's great. We know we have skills in that. Yes, approved. And it never has to know that, in fact, they're not. They're only related in the reason that I like it the most. And this is my 1-minute sales pitch for using that. Well, the first one is it doesn't try to make you think you're in Smalltalk, which is what most test frameworks do because they're descended from unit test and Smalltalk, and that doesn't make sense for a language which is almost the opposite in every possible way to Smalltalk. But more importantly, you can put the tests anywhere and they auto-register. So in particular, you can put the tests in the source code. I don't know of anything else for C++ that will let you do that. And they'll just run. They'll just work, okay? And I like that because the best tests are not the ones that would have been the best had they been written, but they weren't. The best tests are the ones that get written. So you're going to lower the bar as low as humanly possible to flogging people into writing tests because you know they don't want to. And being able to put them there means they're easier to put in, they're easier to maintain and look back and forth, and oh my, I just edited the class, maybe I'd better go and edit the tests. That's the major thing about tooling. Oh yes, Clang format. We actually do have a formatter. We actually do have kind of a standard one at this point because it seems to be as good or better on every point than anything else. And at this point, Emacs and probably the other environments will read it and use its config for your, or can, for your internal tabbing. So at this point, again, welcome your Clang format overlords, and it's super easy to use. And I would show you, but Teresa's not here yet. So the thing to keep in mind is the thing you really want, this will save you only 5 minutes. You want to use Git Clang format. And the reason is that if you don't want to run it on the whole repo very often, but you want to run it every time you're about to commit. And so that's the tool you actually run. I run it so automatically, I don't even need it in Git, but there's a good Git hook for you. You can't commit until it's been formatted. You never again argue about formatting, you argue about the format file. Okay, so tooling, you can actually have it, all right, in C++, believe it or not. Okay, now, let me see where I am here. It goes faster when I don't have my slides. I don't know if that's a good or a bad thing. I could, but then, I'd have to be funny. And I'm funnier when I'm not feeling this rushed and this bad, because I never do this to people. Because I respect your time, and I have failed to do that. So the other thing, I want to mention a couple of other things about tools that look like good ideas, but they're probably not for you. There's this thing called Clang Tidy, which should be your all-singing, all-dancing linter. What it does is really great. Every time I have gone to configure it, it has taken like 10 times as much time as I expected. So it's the opposite of Clang format. So trust me when I say, if you don't know already enough that you don't need to be in this talk, you can give it a miss. Not because it isn't great, but because your boss is going to want to know why you disappeared for a week and wrote nothing. Okay, it just kind of sucks. So I'm going to tell you what to use instead. How many people remember Valgrind? Valgrind? Okay. Now I'm going to tell you why you don't need Valgrind anymore. I still run it, but honestly, I don't really need to. And that's because both GCC and Clang have built-in sanitizers. And whenever I have compared them with Valgrind, they found everything that Valgrind did and more, and about 8 or 50 times faster. There may have been one time Valgrind saw something that they didn't. Basically, that's what you do. And if you're not using Clang or GCC, you should be following my last piece of advice, which is compile with more than one compiler, okay? You want all your tests to pass. Any compiler, any set of flags that don't actually change the semantics, in particular, just run them with the sanitizers on. That's your test. You probably don't have any memory leaks if it can't find it, and you probably don't have you have a pretty good chance of not having race conditions if you use the thread sanitizer and you did something basically sane. Thank you, Eric. All right, so you might get to see code. We'll see if I have enough time. So the deal with the sanitizers is that my point was, if you're using some other compiler, you still ought to be using Clang or, okay, here we go. Clang or GCC, because different compilers will catch different things. And then you can run the sanitizers. So no matter what you're doing, if you can't do that, then I honestly don't know what in the world you're up to. And so that's the advice. Now let me see if I actually have things here all set up. I'm supposed to. Aha, that looks very promising. Very much like it's actually working the way I want it to. So let's go ahead and, wait a minute. It's mirroring the window, which means I can't see my notes. Can I fix that really, really fast? How do you fix that? It's not there. Where are the settings? Options. It might be here, or it might be. Does anybody remember where, okay, that's not what it is, so it's probably, does anybody remember where I have the settings so that I can tell it? I can't hear you. View, okay, very good. Okay, which is where? Oh, the Windows settings? Oh, you might be right on that, actually. Yeah, that sounds right. I fixed this at home. There we go, 1, 2, so I need to tell it to, it's duplicating, and I want it to extend, I think. Don't think so? You don't think that's it? I think it's right. The one question is whether I have the right, yeah, the problem is I don't know. Does anybody know what so wait a minute, it probably says it right here, doesn't it? 1920 to 1080, which is, I thought, what it was. See, this is why I should be here way earlier than this. Okay, now. The one thing I don't quite get, let's see whether this is actually going to display correctly. I'm a little worried about that. Oh, no, it did. Awesome. Okay, so first of all, there's the repo. The only thing the repo doesn't have are the slides because it turns out I edited them, and I will push them up forthwith. But I think you'll have every piece of code that I will show you. So tell me when I should move on, because I want to give you a second to actually to clone it if you would like to clone it. I might get through this talk and you might not hate me by the end. That's a good sign. It's always good to lower your expectations to what's achievable. Maybe. Okay, you guys ready for me to move on? Okay, if you don't have it, ask your neighbor. And let's see. Okay, so let's move ahead to where I would be. Okay, here's my list of tooling. Okay, is there anything I didn't say? I think I said everything there, didn't I? Okay, so I'm going to show you. That's why I was kind of hoping, I was stalling a little bit trying to do everything else. And the reason is, there we go. I pretty much said that. The reason is, now what I want to do, that's slide 23. Now what I want to do is, and let's see if I can get, because Emacs should be running. Oh no. What in the world? I think my VM crashed. I can't believe it. It says it was aborted. Okay, all the code is on this little machine doesn't have enough disk space for me to do what I want, and I was running Unix in a VM. That's disturbing. All right, if you have, okay, it'll kick up in a second. All you need to do is to look at the top level cmakelist.txt file. What you will see in it is a bunch of build types, which I should replace with something more modern, but I'm still kind of wedded to it. And one of them is called sanitize, one of them is called threadsam. If you look at those, all they do is add something like -f, and then the name of the sanitizer, sanitize equals, it's built in. You don't have to install anything. If you have GCC or Clang installed, you have the sanitizers, you just use the flags. And the only reason that you don't run them on the main one is that you're going to probably want to recompile your release without it. Did I just fumble finger that? I fumble fingered it. If I talk and type at the same time, bad things happen. So let's see if I can get this. So I realized that I didn't know my VM would have crashed, which is really odd because it never does that. All right, so I run the VM more than I actually use Windows. Surprise, believe it or not. So what I'm going to do for you. All right, so what I want to do is okay, so Spacemax will take a minute to go up. Here's what I'm going to do. I am going to, I will come back and show you exactly what that means, okay? So the first one, so now that we've done all of that, what I really want to talk about are the two things most likely to go really, really badly wrong, because I'm assuming you can program, but there's no reason you would have any skills for manual memory management unless you have used either C, C++, or something even older. Rust doesn't count because it's not really manual. It's really beautifully automated is what it is. So what are we going to do here? All right, so you have options, okay? And here are your options, and I'll just give you a clue right now. There's only one right choice, okay? If you don't choose a memory management option, or if you do and you screw it up badly, what you're actually using is the big ball of mud system. I hope it's obvious to you that that's not what you want to do, but in some sort of mystical way, even that, which has nothing to do with the syntax of the language, is still the default, is the big ball of mud, okay? Shared pointer. Now, shared pointer is great, but I kind of dislike it, and it's not because it's not great. It's because people use it as a get-out-of-jail-free card. They don't know how to manage memory, but they know how to work in a garbage-collected environment. So they read shared pointer as, this piece of memory is garbage collected, you get out of jail free. And it's not true, but it works long enough for them to create some sort of freeing, cycle-freeing system that they can't understand, okay? It's also kind of slow. So what you do with this, there is a correct usage, and what you do is you use unique pointer for everything except the one set of chunks of memory that would have altered your architecture for the worst. And then you use that, and it's great, it's awesome. But it's not a way to get out of doing it. Okay. The bump allocator there, I'm not going to talk about it. It's very specialized, but really awesome. I only have it there to remind me, to tell you that you probably did not learn that there is one in the standard library. You could fiddle with it if you want it better, but you can just make that work. So that's the whole point. STD, PMR, monotonic buffer resource, and Bob's your uncle. I don't know who Bob is. All right, so the right thing is unique pointer. At that point, let me just go ahead and double check. Let me just double check and see whether my VM now is ready for actual reasonable behavior. I think it is. So let's do this. So I'm going to now go backwards slightly. Hang on. Okay, there we go. There we go. Hello. Wake up. There we go. Can I get this to where you can see it? See, now here okay, so there is something wrong with the resolution. Oh, you know what it is? It's set for 16 to 9. That's what the problem is. I also use Space Max. That's why it crashed. You know what? I totally believe that. Space Max is really awesome, but it's using Emacs as its, it's using Emacs. And I mean, God love Emacs, but okay, what I don't know where I can tell it to use, what is it, 5 to 3? 4 to 3. So I don't know how to do that. I might, so that's going to be kind of, so everything really that I could have imagined going wrong has gone wrong at this point. So yeah, so you're actually learning. So this is a day in the life of a C++ programmer. Thank you for reminding me. All right, so here's what I'm going to do. I'm going to just, I'm going to do this the way that cavemen would do it, which is I'm going to shrink the window, and I'm going to try to actually look at it over there. So let's see if I can make this work. What in the world? Okay, you know what? Yes, but it should slide over there, right? It should go onto the monitor. All right, you know what I'm going to do? I'm going to mirror it because that would be less ridiculous than this. And I'm going to somehow I'm going to get this talk to actually, sort of work as well as I can. So here's what we're going to do. The mirroring kind of worked, didn't it? Okay, so that's what we're going to do. Now let's see what happens if I duplicate it. Okay. All right, it's probably going to have problems, but I may be able to fix them by simply shrinking my window. I really don't. You know what? I've done this so many times, and I've never had this problem. But, all right, let's take a look here. All right. Kind of usable? All right, this is kind of crazy here. It does that if I resize Emacs because it's crazy. All right, so here we go. All right, so what do we want to do? Open this. Yeah, I will make it bigger in just a bit. I just want to find what I want here. Hello? 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 All right. All right, tell me when it's big enough for you to read. Does that work? Okay. By luck, notice, so what you have here, this is part of, so CMake has this hierarchical set of configurations. This is the top level one, and I'm making build targets. And if you look here, notice how I have flags that all the sanitizers use. Then I have a thread sanitizer, and then I have like all the rest of them which can all run together. You will occasionally read about the memory sanitizer. If you want to rebuild libc yourself, go for it, but it's not that easy. So all you need to notice is, take a look at the thread sanitizer. It's only doing one thing. All I do is I add -f sanitize equals thread. That's it, folks. And now, as it runs, it's looking for race conditions. If you look at the other one, it's got the most important one, which is f sanitize equals address. And let me see, do I have enough time? You know, let me think, I'm probably a little late. I was going to actually just run it and let you see it catch. Do you want to see it catch a memory leak or no? You want to see it? Okay, let's do that. All right, so what I need is, now first, I need it to start up. What the heck? Okay, here we go. This is what I want right here. This also, okay, so my command line is really long here, but that's okay. Can you read that? Okay, good. So what we're going to do, let me make sure it's up to date. Oh, come on. That's weird. Okay. I have some scripts sitting on top of this, and you don't need to do that, but sometimes it just saves me typing if I can actually type, which is getting a little bit, wait. Yeah. Oh, yeah, make, I'm just saying, yeah, I figured it was already built. Okay, so just quickly, and then I'm super, this is like the most lazy thing ever. Okay, so there are your tests. That's doc test. It says they all passed. So if I just quickly go to, okay, where's my email? I don't believe it. So when it came back up, I've never seen this either. So when it came back, so let me look at I don't believe everything that has happened to me, but I think what's happening is that this window, there we go, that's what I want. Okay, perfect. Okay, so all I'm going to do is I'm going to screw up a little piece of code, and where I'm going to do that is in, okay, here. There's a bunch of stuff that's getting wrapped, and it's mostly for demo, okay, so there's not any serious work in here, but I want you to notice the first thing. Notice how there's a little bit of code up here at the top, okay? Code, tests. See that? Oh, yeah, sorry, I got to do that in every one. Tell me when. That good? Okay, so let's see if I can do this without ending up having problems at the end of the code. Okay, so we have code, and then we have tests all together. You can remove them, keep them in the binary at will. All right, so notice here's something I'm showing you the wrong thing to do. I'm going to take out the delete, okay? So obviously it's going to leak something. And then let's just rebuild it. Even this little laptop can build decently fast. Now look, so the test passed, and the reason the test passed is that the test, there's no way for me to write a test for that, but notice the leak sanitizer kicked in. Notice what it said. Okay, so there's some C++-like terrible error messages. Direct leak of 1 byte in 1 object, though, that's nice. And where did it leak from? It leaked from scoped init, line 88. Okay, so let's go to line 88. That's the new line. There you go. Now, if that had been 8 calls down the stack through 5 different files, then you can see why I really, really like this thing, okay? So let's just go back now and make things work. Okay, and then I will go back to, we will almost immediately come back, but let's just make it so that it's in a state that I can understand. And all right, so we're almost back. Okay, so this is the you have no excuse slide. Okay, memory management. As I said, there's only one right thing, okay? Basically, it semi-enforces ownership, which is great. It would be nice if it fully did it. If it did that, we'd be programming in Rust. And that would be great, but we're not, okay? To tell you how, what's that? Oh, I thought I heard, okay, just quickly, to tell you how strong this is, I have taken a ball of mud that was leaking memory everywhere for every reason you can come up with, plus some new ones that have been invented that no one had ever seen before. And instead of trying to understand what in the world was going on and find the leaks, all I did was I found every single spot that allocated memory, and I made it a unique pointer, which of course meant it failed to compile because it needs a little syntax tweaks. So then I start fixing those, and I keep fixing them. And eventually I come to the place where either it wasn't freed, it was double freed, it was used after freed, doesn't matter, because it's going to find it. So what I'm telling you is that you can make your life easy for your sanitizer, because if you do this, you can use it to debug other people's code and improve it simultaneously, or you can make it so the sanitizer doesn't fire very often. Okay? Now, I've told people there's a few best practices. Let me look here, how am I doing? It's a few best practices. I just want to show you something, okay? So let's see, what slide am I on? I'm on 39. Okay, so let me show you something. Again, you may know this, but if you're first coming to this, it's just not that obvious. So here's where I want to go. Actually, I'm already where I want to be. All right, so scoped init here is showing you the ways you can use this, right? See, bad idea, that's calling new. Ideally, you'll never call new again because you'll call make unique instead. There are a few places where you can't use make unique because it calls the constructor. So if you need a hunk of memory with no constructor involved, okay. So the backup plan is only call it once, and you'll see what I mean in a second, okay? So, okay, this is better. Okay, so if you don't know anything about unique pointer, all make unique does is it calls a constructor and wraps a unique pointer around the result, okay? Which means now suddenly it will not let you do most of the bad things that you might have done, but that's not the best idea. Let me show you the best idea here. Okay, I want you to look at this, and I'm going to show you where it came from. Notice I'm auto, because why should I type a whole bunch of garbage? Class, I'm calling a factory function in the class, aren't I? Okay, so now what we want to do is look at the factory function, which is in the header file. Okay, now I got to do it again. I think that's about where it worked, is that right? Okay, now notice a couple of things. Do you see these aliases up here? Use aliases a lot. Because anything involved, okay, the template syntax is a nightmare to read. If you don't think so, then you have Stockholm syndrome, and you should try to get over it. So what you do instead is you can use aliases to give them names that mean something to human beings. So please do that. Make a lot of aliases. You see this already is good, and there are actually places where it actually is saving me a lot more than that. So go down here. This thing, the only thing this does is initialize and finalize the OpenSSL library in a C++ way, which always means I'm going to automate it with RAII. In other words, I'm going to use a destructor. But notice, here is this inline function, so it costs me nothing, and it has a name for what it returns, so you can actually say it instead of a whole bunch of template garbage. What does it do? It calls make unique. Now, the only thing is, because of that test, I didn't make the constructor private. In practice, I would. The only thing that you would be able to do to make one of these things would be to call the factory, which only returns a unique pointer to the thing. That's the way you should really do it. Call make unique once, and then you have protected your borders and enforced the rule that nobody's allowed in the kingdom without being decently naked. They have to be decently clothed in a unique pointer, okay? That's what I wanted to show you for that. Now let me go back. Okay. All right, here we go. Okay. See, impossible to not manage memory. Okay, it's in scare quotes because you know I'm lying, but it's much harder. Okay. Here's the problem with telling you to only use this, okay? And I'm thinking of almost everything I say here that sounds like an exaggeration. I could name the specific company and project if I weren't under an NDA. And if I'm not, they'll put me under one just so I don't tell you what was going on in their code. All right. So the point is that it doesn't actually work if you just read the docs, because they'll tell you how to use it. What they won't mention is, in the real world, you're probably stuck using OpenSSL for all your encryption needs because it's the only thing that everybody has, right? And OpenSSL is a C library. And if you're lucky, it's using C-malloc. But it might be configured to use its own special malloc, which means you have a third memory pool. And God help you, there may be every library could do that. So what I'm going to tell you is how to actually do what I said. I've told people to do this, and then I realized one time I didn't ever tell them what you can do, okay? So here's how we're going to manage every single piece of memory. Okay, I want to show you something. Okay, so back to Emacs. Okay, so first of all, since my notes no longer just show up for me, I think I've done this enough to actually just do it. You know, the way I come in here like this, you'd think I never actually practiced this, so you'll just have to believe me that I really did. Oh, here we go. I mean, you know, I hate to ask that of you. Well, let me see, where am I? Oh, this is the include, so I needed to, all right, let's go down. Oh, that's too far. Okay, so what we're going for is the one that's not open, so I can't see it. Okay, now, all right. Okay, so this thing is deleter. This is like the only thing that's as simple as that little init thing, because it only had a constructor. This is even simpler. It has one member function, but it's operator parents, so it's a functor. All it does is it calls a function for you, okay? That's all it does. But the great thing for it is this is what you need for a deleter to tell unique pointer how to free memory. Okay, because you're not going to use the default one. And what that means is that all of our troubles almost are going to go away. Okay, so first of all, if I show you, well, I'm getting fast at that. If I show you the test case, you'll see exactly what happens. Okay, here's a case where I called malloc. Yeah, you can see my cursor. I called malloc, okay, and that's okay because I can initialize a unique pointer. But notice that the deleter, the unique pointer has a second template argument. It's a deleter, which is templated on the C-free function. And that's all you need to do. And this is all at compile time. I don't think there's a runtime penalty, except, anybody know, this might actually create that functor. That's possible. Okay, so the point is that that's really nice. The other thing that you can do is you could make one, this is the other way. There are two ways. Just in case, I'm going to show you how to use the template argument thing for anything you want. Just so you know, there's a second way. If you look at this, I just templated it on the type of the free function, and I passed in the free function. That works, but it works at runtime. So the price of that is, number one, you have to remember to put in free. Now, I realize none of you will ever make that mistake and fail to put it in. But I want you to think about your coworkers, because you know who won't do it. That's the first reason I don't like it. The second reason is that now unique pointer is twice as big, because that has a pointer to the free function. So on the whole, I prefer it the other way. That works. Now you say, well, okay, that's fine so far as it goes. Now what I want to show you is this. Remember I said protect your borders? Okay, I gotta make it big again. Is that what I want? Yes, it is. I had this all set up. Everything was already made big. So, you know, you can imagine that I'm giving a much better talk than I am. Yeah. What's that? This one I can do almost without thinking. So I'm not gonna learn anything during this, because that sounds like, you know, that sounds like about as bad as asking somebody to do threads the first time by doing it lock-free. Okay, again, more aliases. Why? Because all the reasons I just said. Notice there are two here, because C does not distinguish which kind of thing I'm pointing at, but C++ does. So you can have an object pointer, which then has a couple of extra methods. So you can use the arrow operator to dereference and star to refer to it, or you can say, no, it's an array, in which case it has subscripts. So you want both of these. So now that I've made that readable, look, I have a malloc function. Okay, what does the malloc function do? All it does is it makes it look like I want my library to work. Well, I'm going to call malloc, okay, and then because I've chosen to use exceptions here, I'm going to throw bad alloc if it returns null, because I want everything to work the same, right? Okay, and then I'm just going to return, and this is where it pays off that I actually named the thing. By the way, I didn't say this. Do you notice, if you don't remember this, you can make your aliases, you can make templated aliases, and that's really hugely nice, but if you didn't learn that, you learned it wrong. Now, I have two mallocs. Why? Well, this is C++, so I don't have to have malloc and calloc and realloc and blah, blah, blah. The point is, if you pass in an element count, then it calls this version that not only knows how to get the right amount of memory, but it returns the array version, right? Okay? Notice how nice that is, but notice how nothing inside the kingdom actually does stupid stuff, right? Okay, now that's nice. The other thing is, just to show you, I might have actually not had time to really show you this. The point is that if you want to do something like stirdup, it's going to call malloc for you. So what do? Of course you do. You wrap stirdup so that it returns your new string in a unique C array, right? Obvious, right? But the point is, it's not obvious. So if you use OpenSSL, I really started thinking about this when I realized that OpenSSL probably has more free functions than I have fingers and toes, because it'll have them for these complicated, and a lot of very good C libraries will have a free function for a complex object that knows how to walk down the tree of stuff and free each one of them, right? But this works for those, okay? So now you actually can do what I said and use unique pointer for pretty much absolutely everything, all right? And that's what I really wanted to tell you. Now, what's the last thing? How am I doing on time? You know, I'm okay. In fact, it's going to be a little early because, as I said, it's faster. Maybe I should do this without slides more often, huh? All right, so here's the problem, okay? So remember, my imaginary target audience is a guy who had the terrible judgment to admit to somebody in the company that he took a C++ class in college, and it probably only was a data structures class and didn't do very much. But the problem is something has to go faster, right? Because if it's a company that only hires JavaScript programmers, why do they have a C++ project? You already know why. It's only for performance, because they hate it. They don't want it, but they've got to have it. And now you are responsible for that. And these days, that means you're going to have to thread it. Right? Okay, there are a lot of ways to thread things. Some of them are even sane, maybe. But the point is that if you haven't done low-level threading before, then this is not going to work out well for you. And I want you to actually succeed, because if you fail, they might call me, and then I might have to read your code, and then I'll be under the desk, huddled up like this, crying and, thinking, I only have a few more decades to live. So I'm going to try to show you how to survive the first time, okay? Or at least give yourself better odds. All right. So first of all, this is, oh, wait a minute, I didn't actually do that. Okay, so first of all, wrong way here is a little different. There's not, if you have the time and you're really going to learn this, of course you're going to start with the low-level stuff. The problem is, I'm imagining that this was not what you wanted to do with your life, and so at this point you need to produce something. It's probably not as productive as you would like to start with these things, because it will tempt you to use them in practice, and that will lead to long debugging sessions for problems that you'd never thought of before. So here's what I'm going to tell you. I'm saying this is not wrong if you want to become an expert. It's wrong the first time under time pressure, okay? Or if you have to have somebody else take care of it. So what's the right way? Okay, here's what I'm going to claim. I'm going to be stupid enough to claim this in front of some people who really do know how to thread, and I'm going to make dogmatic statements because that's the way I roll. Here's the way you're going to get it right, and I have done this and gotten it right the first time. I know it's possible. Now, having said that, I'll never do it again. All right. What you do is you only have one synchronization primitive. You're going to use queues, nothing else, okay? You're also going to develop it in a particular way. You're going to always have a build option that lets you build it single-threaded. And you're going to completely debug the logic single-threaded. Got it? You're going to have a good test suite that actually has coverage instead of what you usually write, because the boss doesn't actually pay you, doesn't actually credit you for the time to write tests on your performance review, right? Okay, but you're going to do that because you're saving yourself 10 times as much time later. Okay, having done that, now you're going to run it with threads. But you're not going to run it with the high-performance queue that you really want to achieve your performance goals. You're going to run it with something that's so transparent that you can sort of understand it, and furthermore, it's too simple to be wrong. All right, so you're going to have multiple build targets, and you're going to debug it first with the simple one. And if you think I'm over-exaggerating this, this is how I got it right the first time. I had already done all of this, and then I handed it over, because it sure wasn't right the first time I ran it. It was just the first time they ran it, okay? And I say that because all the problems they had weren't my fault, and I was gone before they found whatever it was that I probably did wrong. So I'm going to claim that. All right, so look here. Let's see, where am I here? Why is it not? Oh, that's odd. Okay. Oh, all right, so the point is, this is odd. All right, so let me just see something here, because what I don't understand is why it's not letting me. I don't believe it. Did it just freeze on me? Oh, crap. It was going so well. I was almost there. We almost got this. All right. I actually don't know how to get it to even unfreeze at this point. That's very strange. Has anybody ever had, all right, you know what I probably can do? I hate to do this, but it is Windows, so I'll blame Windows. Oh, that's interesting. If the task manager doesn't come up, I'm in trouble. Hang on. Let me cancel it, because it might look, well, let's just do this. Oh, and now I think it just crashed. So I don't think I actually have to do anything. Thank you, OpenOffice, or LibreOffice. Thank you so very, very, very much. Let's see. Yeah, my VM is fine. Let me just see if I can quickly make this work. Maybe. It was going so well, folks. Recover selected. Okay. Wow. This is what I get. You know what this actually is, don't you? This is the divine punishment for bringing a Windows machine to scale. It really, really is. There's no doubt about that. There's no doubt. Even though everything was actually done in the VM, this poor little machine needs a bigger disk. All right, so where are we? Okay, there we go. We've got all of them. So here we are. So what this says, okay, so here's where we were. Okay, so here's where we were, right? Okay, what did I put in the repo? I actually gave you a fast lock-free queue. It's an interesting queue. It wouldn't be the fastest thing for everything because it basically busy waits. But if you really are slamming it hard, that might be the fastest thing you could possibly run. So that's my example. It's there because, let me tell you, it's a black box to you, and don't try to read it. Even if you know how to thread, it's probably a black box because it's playing a lot of games. Although its biggest thing is it doesn't do anything smart. It's just stupid fast. All right. It also has a documented queue. Now listen, you go, well, what's the simplest queue? Okay, this has the best documentation you could possibly have. This is the best book I've ever seen on C++ concurrency. All of the example source code is available with the Boost license off the author's website. There was one missing line, but I fixed that. But the point is that if reading it isn't enough, you can basically just read like 3 or 4 pages explaining the whole thing. And it's stupid simple. So the point is that it's almost too simple to fail, except it's threading. That's how you're going to know that your threading logic is right. And then you put in the other queue with some confidence that if you have a problem, it might not be you. But to do that, you have the problem that you want to be able to, I'm actually out of time, aren't I? All right, I will show you afterwards. What I want to do is I want to make a point about this, because all I was going to show you is, what I did in there is there's a wrapper, okay? The wrapper has the uniform interface, the only interface you'll ever use for a queue, and the template it's templated on the queue type, and it's specialized to call that queue and to turn it into what you want. It's really simple. I was going to show you, but I'm not sure that it's worth it since I'm done, basically. But the point is that that's what you do, so you can swap things in and out, right? And if you're really, really unbelievably paranoid when you're in single-threaded mode, you could just stick in stdq, right? Okay, so the point is that it'll just do what you want, okay? Now, here's why I want to tell you. Why do you use this thing, okay? How are you going to use it? Because That's still not obvious if this is your first rodeo, right? So here's what you're going to do. This is what I call the simplest right thing. It's actually fairly hard to screw up, even if you haven't done threading before. You can do it because it's threading, but it's the one that's the least hard to do, because not only does it only use cues to synchronize, but it does it in a way that's fairly intuitive. You might have even done something very like this with server requests, because all you have is you have two queues. You have an input and an output queue, and I did something that I would have shown you, which is in that queue wrapper, it has little handles, and all they are is, I want to call them smart pointers, but they're dumb pointers. They're too dumb to let you do something you're not supposed to do, so that the producer only holds a producer handle. It only has two methods. You want to push, or do you want to try push? Do you want to block and push, or do you want to not block and push? Okay. Same thing for the consumer. The workers obviously pull from one put to the other, but you notice the red thing that's called out, and that's the only thing that I really want to show you on this. Besides, if you see this picture, you can probably write it, okay, without actually anything else. Okay. Now, why is it red? Okay, this is what makes this fairly flexible, in spite of it being really simple, which is that the workers are allowed to push tasks onto the queue. So you can break your jobs down into chunks and have them done separately. Why would you want to do that? Let me tell you why. First time I did this was for a very specific reason. Worker does some work, then he has to call out over the network. Okay? And that suddenly means that what I don't want is for my entire worker pool sitting there hung on a network connection because the back-end server went down. So what you do is you do your calculation, you get ready to make the server request, you send it off, and then you throw it back on the task queue with a different thing, with a different task in it, right? And then the next guy that pulls it off, he looks, is there data ready? If there's not, well, I'm not going to waste time. I'll just stick it back on the queue. So it sits there and recycles on the task queue. And if you do that, you can do a surprisingly large number of jobs, okay, with the same thing, and it's probably the simplest thing that is really useful and will probably work for you. And then later you can go back and read about locks and atomic operations. The one thing I need to tell you is there's one rule. The reason this is simple is that it's only simple if you do what I said and you don't use any other synchronization. If you try to do anything else, like I just want to message them and I want to tell them all to shut down, you can't do it that way because now you have to think about race conditions. The whole point was you didn't have to think about race conditions. So instead, you just stick a message on there, right? And it says, oh, everybody's shutting down, so I'm going to push this back on for the next guy, and then I'm going to exit. And the next one does that until the very last one pushes it back on, and then he exits. And then you can empty it from a controlling thread. Okay? My point is that if you do that, you have a decent chance, okay? Oh, by the way, that's actually pretty good for throughput, just as it is. If you want low latency, I came up with some tricks. Probably won't be quite as efficient. It's pretty good. I want to say something about scaling. You say, well, yeah, but I'm developing this, and I've got exactly 2 cores on my laptop. You probably have more, but this little machine's kind of getting old. But we're going to scale it with 10,000 worker threads. Okay, this won't scale to 10,000 because of the contention on the queues. It's fast because it's stupid. Okay, so what you do then, though, is you say, well, I can use the same logic. I'll just go find a fancy queue that's quite a bit slower with 10 worker threads, but then it does all of these clever things like underneath the hood, I've got like a queue for each one, and I'm doing work stealing, and okay, you can do all that stuff under the hood. So the fact is that your logic is still the same. You just put in a slower but much more scalable queue, and now you still are within that realm where I'm not an expert yet, but I'm going to get this finished, and then I'll go and I'll read what in the world, test and set means. Okay, so that's it. So hopefully we've accomplished 3 things. You have a better chance of surviving your first unexpected and possibly unwelcome C++ project. I'm not going to be under my desk weeping over the code, and there'll be fewer balls of mud in the world, amazingly. All right, that's it. Thank you. I swear to God, I did not want to illustrate what a day in the life of C++ programming is, although it was surprisingly accurate. Yeah. I didn't actually code that up because I didn't think I would have time to demonstrate it. I actually want to make a really nice, so the really nice versions of this that I've done I don't own. So the problem is what I need to do is go and do another one that has all the little tweaks that I've learned and then and then just put it out there. Put out that structure. Yeah. I mean, what you want to do is you want to do things like have some helper things like this is a job that has many tasks, and so the system will go ahead and kind of automatically push the next one on until it's finished without you having to write the logic to do that. That's why it's not written yet. I want a really nice one. And the really nice ones that already exist are not my code. But otherwise, but it's really, I swear to God, this is actually very easy to write. And it's even easier if you use the cue that I gave you there because it already has these little handles that mean you can't call a thing you're not allowed to call. Sure. Anything else? I will push up. Do you have a question or just saying goodbye? Okay, so GCC and Clang are the two leading open source compilers, okay? For a long time it was only GCC because no other open source compiler was like even very serious. And then one day Steve Jobs threw a hissy fit big enough to create a new compiler. I mean, I'm really simplifying, but there's a fair amount of truth in what I just said. Next was dependent on GCC. Apple was dependent on GCC. Steve Jobs hated it because one time Richard Stallman told him no and made it stick. And I'm sorry, nobody tells Steve Jobs no on anything without Steve throwing a fit. And so Steve eventually used Apple money to take a really nice thesis project. I can't remember his name, but LLVM was a really nice thesis project. And he said, well, if that's such a great compiler kit, then let's make Apple's new compiler, and then I can give the Bronx cheer and a stiff middle finger to Richard Stallman. I mean, look, I'm not far from the truth when I say that. So two compilers, okay? And they're very similar because Clang, the only way Clang can be adopted is to be flag compatible with GCC. So very easy to switch. But the Clang project has many other things because LLVM isn't just for building compilers, it's for building tools. So they have tools around it, and there's something called Clang format, built with the same stuff. You can use the parser from Clang, so you can use an actual industrial strength parser to build tooling. It's a really nice system, so don't let my sarcasm fool you. And so there's this thing called Clang format, and all it does is it'll go through all the files you give it, and it will re-indent them. It only touches white space, and it will reformat and indent them to be whatever you told it to do, okay? And it's really easy to use. Though, the one thing I didn't say, because my slide didn't remind me, is it has 1 million configuration options because it has to. So nobody ever starts by writing each one down by hand. You grab an existing one, and then you look at what the results, you say, I don't like that, and then you go and you find it, and you keep iterating that until it's close enough to what you want that you're just too lazy to go change the next one. And that's how that works, okay? If you want to use LLVM's coding style, you can actually just say that. And you can also tell it, I want to start with that. Please spit out your config, what the config is for LLVM style, and you can use that as your base, okay? God help you, you can use Google's. The point is that it's very easy to get going. You just find an existing config and you keep playing with it until you just don't feel like playing with it anymore, okay? It's like using, I think Black does that with Python. Yeah? Okay. Does that answer the question? Sure. Anything else you guys want to talk about? I'm here until you send me out. Yeah. What's that? The slides will be in the repo. It's just that I was tweaking them this morning, earlier, and so I hadn't actually pushed it up yet. So after this, you already have the URL. I'll just push it up and merge the slides in the doc subdirectory into the repo, and then you'll have everything that I just gave, and then I guess I should label it. This was the state of the repo when I gave the talk. So it's amazing how, Git is useful for stuff like that. Surprising, isn't it? Okay. Anything? Yeah. What point did it break me? I was going to say a no because I don't do 1 minute, as you've already figured out. But, okay, so the short answer is that I learned C in Kernighan and Ritchie C without prototypes. That's some time ago, because I remember converting code to ANSI C. That was quite a while ago, 35-ish more years ago. About 5 years after that, I started transitioning my C style to what I would call object-oriented C. You'll see this a lot. That's my mature plain C style. And that was also because I was actually getting my head around how I really wanted to do object-oriented programming. Then a year or so after that, I started working in C++. So probably in C somewhere around 87-ish, 86 maybe. C++ would be, okay, when I started using C++, the Linux distribution, the big Linux distribution was Slackware, because soft landing Linux had just lost popularity. So it was probably before the 1.0 kernel. See, I'm dating this in Linux time. You've heard of Unix time, right? This is Linux time. Okay. So that may answer your question, but it wasn't in 1 minute because I have no idea how to do that. Oh, yeah. When did it break me? Okay. Can I use C, or does it have to be C++? Okay. Because the time that it broke me the worst was C. All right. So I did some embedded, basically I was extending firmware with cryptographic stuff, and it was threaded. So it involved cryptography and threading. So you can kind of see that this is heading into dangerous waters. And so my stuff all worked. So I said, all right, it's well tested and everything. And that's good, because we were just like a day, well, we were very, very short ahead of a deadline. And then I get somebody sends me a Slack message, and he says, it's not working. And so I have to debug it on the machine, because it turns out that all my tests worked on x86. They didn't pass on, I'm trying to remember if it was ARM or PowerPC. I think it didn't pass. Oh, yeah. See, this is the worst part of it. What happened was that they passed on x86, where I developed it. They passed on ARM, which was the tiny development board we had. But the real boards were super expensive, okay? Like, you buy a car for something slower than your watch kind of expensive, because you were actually paying for the brains of the guys that wrote the cryptographic firmware that I was extending, all right? It's an HSM. So the point is that we had the really cheap one. You weren't even supposed to know that you could use it from Linux. And the trainer told me under the table, oh, you can actually do that. And then we used that for development, because we didn't have the money to buy, an extra car in. Okay, so the point is that we received the big board, days before we had to go to a conference, and they were going to announce something. And the big board used PowerPC. And it didn't work. I didn't sleep for many, many, many hours, and I'm too old for that. And the worst part of it was, so I was sure that I'd screwed up the endianness, because PowerPC was running in big. What else would I do? It doesn't make sense. It wasn't that. And I chase it, and I chase it, and I chase it, and I'm debugging this little board. So every time it's like, okay, now squirt it over to the board, and then, so it's really awful, okay? And I'm reduced to printf debugging. There was probably a way to make GDB look at it. I had no idea. So I finally chased it down to a call into the crypto library I was using. And then I go like, oh crap, now I'm really in trouble, because I don't really have a replacement for that crypto library. So I keep on chasing it down, and finally I have the function, okay, printf. I'm doing this, taking me forever. And I finally get down there, and it's like at some point in the function it just isn't right anymore. And The only thing that saved me, the darkest hour was right before I got into the library code. Because at that point, I had an excuse. But I'll tell you what, the closest that came to breaking me was it's like nothing makes sense anymore. I finally get in there. So here's what happened. On PowerPC only, possibly only on Big Endian only, that version of GCC only, which was the only one you could use because it was the one that was certified, right shift shifted garbage. Because it was a 32-bit ARM machine and it had to emulate it on 64-bit. So it only broke on 64-bit right shifts because it was in the tiny little emulation library. And I thought, how did they miss this? But it turns out the vendor who had picked the board never used 64-bit operations because why would you? They're slow, they're emulated, so they did it right. But the only library that I had used 64-bit words because he was imagining I'd run it on x86 64. So the bottom line was that didn't work. And then I didn't know what to do. And then finally, so I bucked it up the chain of command, and then eventually, so it turned out that the guy who knew what I wanted was in France. Because an American company bought a French company. So I had to wait until the sun came up on the other side of the Atlantic to get responses. And I spent several hours in a white-hot thing taking all of this code and breaking it down into an example this long. So they couldn't argue with me because I knew what they were going to say because I would say the same thing. And I sent it to them, and after the sun came up on the other side of the Atlantic, I got this email back and said, I tell you what, try using this version of GCC. That's the one that we're going to use in the next release. And I emailed them back and I said, sounds great. I don't know how to make GCC cross-compile for your board. And so they held my hand. And I got GCC to cross-compile. But before I had I wasn't okay because we had this deadline coming up. I was not okay until I had a cross-compiler working and my code worked. But the darkest time was probably when I still was convinced that I had screwed up the Endianness and I was just mindlessly sifting through my own code. Okay, so that's that. I don't think anything quite that bad ever happened in C++, but yeah, you're welcome. I like the question, I think. Now I'm going to have to go back and go into therapy because now you've reminded me of it. All right, I hope that was useful. I'll stick around if you want, but I don't think it's fair for me to not say you're free to go. And I hope that was useful for you or entertaining, or at least it's fun to watch the monkey dance, trying to get his tools to work. So one way or the other.